Hi, I'm Luis Gabriel, and this is my evaluation of the period one. Here is the first exercise that I did. That is the exercise 11 of chapter 2, where I had to construct the ensemble averages. And for this week, I had to compute the mean across different subsets of responses, as we can see in the code. Each of these averages progressively reduces noise, and theoretically, the standard deviation of noise decreases, as where is the number of responses averaged. Next, we plot an individual evoked response and compare it with the full ensemble average. And as expected, the ensemble average reveals the underlying signal more clearly, with noise significantly reduced. And to estimate noise, we subtract the actual noise-free response from each average waveform. We then compute the standard deviations. And finally, we compute the actual noise reduction with theoretical predictions, as we can see in the results of the average versions. And above them, we can see the graphs of the results of the time in comparison of the ECG. Then for the exercise 3 of chapter 3, we need to find the Fourier series of this half-wave rectifying sinusoidal waveform below using an analytical method and also taking advantage of symmetry properties. And for this exercise, first, we need to define the function of and periodicity. The given waveform appears to be a halfway reduced cosine function, meaning that it follows the following integral. And since the waveform repeats periodically, its fundamental period is t equals to 2, as we could see in the graphic. By inspecting the waveform, we confirm that the xt is even, meaning its Fourier series contains only cosine terms. Then we have a Fourier series representation of an even function, as we can see, and where the Fourier coefficients are given by the next parameters. And since the function is even, we integrate only from 0 to t over 2 and multiply it by 2. Then the DC component is evaluating the integral. Thus, the DC component is the next integral that we use for a0. Then we compute an using the next integral to to identify the value of ao and evaluating from 0 to 1. And since for all integers k all term vanish except for n equals to 1, where we get a1 equals to 1 pi. And for odd numbers, the coefficients simplify to for even n, an equals to 0. And finally, we got this Fourier series of the halfway rectifying cosine waveform in number 5. Then for chapter 4, I decided to do exercise 15 and in this case, the signal is sampled at 50 hertz. And I had to compute on average PSD using the entire signal length for spectral estimation. Also applying the Welch method. And as we can see in the code, the window size set to 100 samples. And the overlap ensures smoother results by maximizing data usage. And finally, we plot the results. The first plot shows on average PSD. It means that more variance and noisier. Then the second plot shows Welch's average PSD. It means smoother and revealing key spectral peaks. And finally, some key concepts that we decided to apply in this three exercise, like the noise reduction, the averaging, the comparison between signal and noise, and standard deviation that we could see in mostly in the two codes of MATLAB and in the Fourier series. It was pretty much an analytical procediment to reach the waveform, the final waveform. That will be all. Thank you.